This lesson is going to be on 3.1, symmetry and coordinate graphs. So we're going to take a look at how to test for symmetry on graphs. So I have a table here. In our table, we're going to take a look at symmetry with respect to, so we'll have different things we're looking at symmetry according to, a picture of what that looks like, a definition, and then how we're going to test it algebraically to see what that symmetry looks like. Okay? Please feel free to pause as needed. So our first one is symmetry across the x-axis, and it's going to look like this. So here's our x-axis. If we were to fold on that x-axis, our function would sit on top of each other. That's what we're talking about with our symmetry there. So for example, if we plug in a b or a negative b, we are going to end up with equivalent equations. Here's also a numerical example about what that looks like. All right. So I'm going to show you that test over here. This is the equation of our graph over there. And so we're going to test if we plug in AB or if we plug in a negative B, if these end up being the same equation at the end. All right, so I'm going to say A equals B squared minus 4. Nothing to solve there. Okay. On this one, I'm going to have A equals negative B squared minus 4. When I square that, I'm going to end up with A equals B squared minus 4. And you'll notice that these two right here, they're the same. So we would say that, yes, this is symmetric across the x-axis. All right, our next symmetry we're going to take a look at is symmetry across the y-axis, right? Which would be like this picture here. If we were to take our parabola, fold that in half, it would be equal. Our symmetry test for the y-axis is AB and negative AB. These are points that also fit on our line. Our parabola, and then same thing here. If we input those, we would also get equivalent equations. So my equation down here is the equation of a parabola. It's actually not this exact one, but you get the idea. So I would plug in A, B, same thing. So I'm going to plug that in. I would have B equals A squared plus 4. And then I'm going to plug in negative AB. B equals negative A squared plus 4, and I'm going to solve that. And we'll notice right here, our last equations, they are the same. So in this instance, we would say, yes, it is symmetric across the y-axis. Okay. An equation can be symmetric across multiple of them, so we'll also take a look at that here in a minute. Right. So the next one we're going to look at is symmetry across the origin. So if we take our graph, twist it around that origin, it would sit on top of each other. How we test that is we replace our x with a negative x. Okay, so we put a negative x into our function here, and that would create the opposite of the original, or by making it negative of the whole y. So I'll show you what that would look like, the origin test. This is two problems right here. So I'll take a look at this g of x separate. So if I take a look at this first one here, the f of x, so first I'm going to do is f of negative x. I'm going to take my x and I'm going to make it negative. And we know that a negative to an odd power just makes it negative in the end. So that would be the answer there. And then I'm going to test, what if instead I just make the whole function negative? I would end up with that. And we'll notice our two ends here, they are equal. So we could say that, yes, we are symmetric across the origin. Okay. Let's take a look at the second one. Okay, different problem. So I'm going to take my x and make that negative. So I'm going to have negative x over 1 minus negative x. Okay. And that's going to equal negative x over 1 plus x. So that negative and negative equals a positive. Right? And then there's nothing else I can do to simplify. So now I'm going to take my whole function here and I'm going to make that whole thing negative. When I make that whole thing negative, I am making either the top negative or the bottom negative, but only one part of that is negative. So I'm just going to attach that onto that x, which I end up with this function. So if we take a look at these two, the two end ones, we'll notice that this top one has a plus, this bottom one has a minus. So these ones are not actually the same. So we would say, no, we are not symmetric across the origin here. Two more tests. My next one is across the y equals x. Get it to focus a little better. So our y equals x line is this pink dotted line here. So we'd start the origin, have a slope of 1. Okay, so this is an example of what that would look like. Our test for y equals x, if we put in ab or ba, our function will be the same. This is our equation from over here of what this picture is equal to. So we know the answer should be yes, but let's just take a look at that test and see algebraically what that looks like. So if I plug in a, b, I'm going to end up with a times b equals 6, or ab equals 6. And if I plug in ba, I will have b times a equals 6. And we know that we can just reorder multiplication, so that would be ab equals 6. And you'll notice they're the exact same. So yes, this is symmetric over y equals x, which makes sense. Okay. Our last one is the line y equals negative x. Okay. That is our opposite direction, just with a negative slope there. Our test there is if we input AB or negative B, negative A. So we flip our points and negative both of them. You'll see an equation here. This is the equation of our ellipse, what it's called. So we're going to try that one. So I have AB, and I'm going to plug AB into that one. So I'm going to replace all my x's with an A. 17a squared plus 16ab plus 17b squared equals 225. There are no like terms. I can't combine anything, so I'm done there. And I'm going to put in negative b and negative a. So now my x's need to be a negative b. So I'm going to have 17 times negative b squared plus 16 times negative b negative a plus 17 times, that should be a negative a squared equals 225. So I'd have 17b squared. Negative and a negative gets me a positive 16, and I'll organize that alphabetically. 17 negative a squared is a squared. 225, and then I could rewrite that in the proper order if I wanted to. 17b squared equals 225. You'll notice that my last one here and my blue one here, they're exactly the same. So this one would be symmetric over the negative, y equals negative x. Okay. All right. So my next problem asks me to determine whether the graph of y squared minus 4x squared over 9 minus 4 is symmetric with respect to the x-axis, y-axis, the line y equals x, and the line y equals negative x, or none of these. I realized I didn't grab enough colors out of my drawer. Okay. So I'll start with my first one here, my x-axis. I'm gonna get one more color. Okay. All of our tests here, all of these tests, plug in A, comma, B as our first part of our test. So I'm gonna plug in A, comma, B and see what that equals, because we're gonna compare all of our tests to that. All right, so I would have b squared equals 4a squared over 9 minus 4. Okay, that's what happens when I plug in a comma b. So now I'm going to go through and plug in my test. So my test for the x-axis, okay, was to plug in a, negative b to see if those were equivalent. So I'm going to take my original here and I'm going to plug in a, negative b. So I will have negative b squared equals 4a squared over 9. And I know negative b squared is just b squared. That's all my reducing, and I'll notice that this does equal this here. So yes, I am symmetric across my x-axis. Okay. All right, now I'm going to try out my next one. I'll make my red one my y-axis. The test for that one is negative ab. Okay, you'll see that in your notes above or on the before. And now I'm going to plug this in. So I'm going to have b squared equals 4 times negative a squared over 9 minus 4. Negative a squared is 4a squared over 9 minus 4. And I'm going to check, does that equal that? Looks like it does. So that one's going to be a yes. It is also symmetric over the y-axis. Okay, so the next one I'm going to do is the y equals x. And the test for that is b comma a. So I'm going to plug that in. I'm going to have a squared equals 4b squared over 9 minus 4. All of these equaled b squared, so I need to solve this for b squared. So I'm going to add my 4. I'm going to times by 9. It's going to be 9a squared plus 36. And then divide by 4. And that gives me 9/4 a squared plus 9 equals b squared. This here and this here, they're not equal. So my answer here is no. That one is not symmetric over the y equals x. And then my last one here, the y equals negative x. And I'm going to plug in negative b, negative a, and I'm going to solve for that one. So I'm going to have negative a squared, 4 times negative b squared, all over 9 minus 4. That gets me a squared minus 4b squared over 9 minus 4. If you notice that right here, where I ended up is where this one started. And we know that that one ended up as a no. So at this point, I can just say, no, that one doesn't work. So my answer here is that we are symmetric over the x-axis and the y-axis. All right. It's also going to ask if we are symmetric in respect to the origin. Okay, I left that as its own problem because really it does fit in its own place. So we're going to take a look at what that looks like. Okay, so I have my function here, and I'm going to check if that is if that is symmetric with respect to the origin. So the first test for that is if I plug in a negative x. So I'm going to take my x and I'm going to make that negative. And I know that's going to equal negative x cubed minus 1. My second test here is if I take my whole function and make that negative. So I'm going to put a negative in front of my parentheses there to make the whole function negative and solve that, and that'll get me a negative x cubed plus 1. This one has a minus, this has a plus, so my answer here is going to be no, it is not symmetric with respect to the origin. Okay. Last thing for you, down here this table, it tells us if we have an even or an odd function. Okay. Our even and our odd functions have to do with these notes on the bottom here. So this note down here says symmetric with respect to the y-axis. So in order to check if something is an even function, I'm going to do my y-axis test, and that test is AB and negative AB. Okay, that is my test for if it's an even function. And then my test for an odd function is this one here, respect to the origin, which is that one we just did. So my test for if it is an odd function is f negative x and negative f of x. So those would be our two tests to see whether we have an even or an odd function.